So in this video I wanted to talk about permutations. So what a permutation is it's actually a way to arrange a set amount of elements. So for example, let's say we have our alphabet, so it's 26 letters. So each way to arrange these 26 letters, this alphabet, is a permutation. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, so on, all the way to Z, in that order of the alphabet's order, regular alphabet's order. That's considered one permutation. That's one way to organize it. Now, maybe it can be reordered, right? So maybe you could do B, then A, then all the way to Z, right? That would be another permutation, right? Yeah, so those are, and if we wanted to find out the total number of permutations these 26 letters can be in, so all of them, right? We'd have to think of it like this. We'd have to think, okay, we have 26 positions, okay? And each position will be, will hold a letter, right, from the alphabet. So I'm not drawing 26 positions, it's just to make a point. But these 26 positions are each going to hold a letter, and that's going to represent, one letter. And if they each hold a different letter, them as a whole is going to represent one way to organize the alphabet, and that will be one permutation. And then another way to organize them would be in some other order. So to find out the total number of permutations we have by picking these 26 letters and finding out the number of ways to represent them, right? The total number would actually be equal to 26 factorial, okay? And I'll explain why in a second, but we can actually think about these slots as having a possible number of letters. So this first position can have 26 different letters in it, right? Right? So it can have A, B, C, all the way to Z. And then once it has a letter, let's say it has Z as a letter, this second letter can only have 25 now, because we know that Z is going to be in the first position. Then this one will only have 24, all the way to 1, right? Okay, so we know that each position can hold a number of letters, and we can say that the first position can only hold 26, second position can only hold 25, next position can hold 24, because the options get more limited every time, right? So we do 26 factorial. Well, we can actually imagine it like a path, like from last video. If you have one start point, and then you have 26 different ways that you can go, 26 different paths, so I'll only draw 5, but know that there are actually 26. That's like the first letter, the first slot. So when you're picking your first slot, you have 26 different options. Now, you're at the end of each path, right? At the end of each path, you now have 25 options for the second slot, right? So maybe this one will be A, this one will be B, this will be C, this will be D, this will be E, right? And so on. There will be more paths for every letter of the alphabet. But let's say we went down path D. Now, after you've gone down path D, that means that the first position is going to be path D. Well, the first position is going to hold the letter D. Now, from that, we're going to have 25 different options, okay? We're going to have 25 different options at the end of each path, right? So I'll draw it like that. And then at the end of each of those paths, we're going to have 24 different options, right? And it's getting really complicated, but hopefully you can see the point. At first, you have 26 different options for their first position, or paths, if you will. And then at the end of each of those paths, you have 25 different options for the second position. So it's just like last video with the paths, except it can be represented by paths, just like in the last video. Okay, so last video said that if we have some path, right, and it goes in it has a certain amount of options. So in this case, it would have 26 options, then 25 options, all the way to 1, right? Then you would just have to multiply these together to get the total number of different ways at the end. So I'll draw, there are a certain amount of ways at the end after you've gone down all of the paths. To find the certain amount of ways that you can get at the end, right? And those ways over here, like the number of endings that you can have after going down all of those paths, is actually equal to the number of permutations. So all we have to do is multiply 26 by 25 by 24 by 23 all the way to 1. And that's the same thing as 26 factorial. 26 factorial equals 26 times 25 times 24 all the way to 1, right? So on. So times 23 times 22 times 21 times 20 times 19, so on. Yeah, so you can imagine it like a path. So using the fundamental counting principle, we can understand why we do what we do to find out the number of permutations a situation like this has. Now, when calculating the number of permutations possible, there can be different types of situations. So the situation that we just encountered involved 26 letters and reorganizing all of those 26 letters. But another example of calculating permutations would be just picking 5 positions, just picking 5 letters from these 26 letters, okay? And what we would do then is we'd say, okay, our first slot, so basically what we're doing is we're taking all of these 26 letters, right? We're taking 5 of them, all right? So we only take 5. 1, 2, 3, 4, 5. And we're seeing how many different ways can we take 5 out and reorganize them. So this first position in the 5, right, can be 26 different letters still. It can be anything from this, right? We know that. Now, the second slot can only be 25, we know. This one can only be 24. This can only be 23. This can only be 22. So we do something similar, except we don't multiply all the way down to 1. We only multiply to 22. So it would be, this can actually be represented by 26 factorial divided by 26 minus 5 factorial. And this kind of makes sense because the 26 factorial is assuming that you have 26 positions, right? But when we divide it by this 26 minus 5 factorial, what's 26 minus 5 factorial? That's the same thing as 21 factorial. So by dividing it by 21 factorial, we're basically just getting rid of all of these excess positions, right? And so now we have, that's the same thing as 26 times 25 times 24 times 23 times 22. So the formula really is equal to x factorial, x being how many letters there are in this case, I guess, or how many elements there are in your first group, divided by how many elements you have in your first group, minus how many positions you have. So I'll just write y factorial. So that's the formula for calculating permutations. Okay, let's do another example, except not with letters. Let's calculate it. Okay, let's say we have 5 individuals. Okay, so we have 5 individuals, and we want to find out how many different ways we can pick 3 of them. All right, we have 5 individuals. We want to find out how many ways we can pick out 3 of them and reorder them in some way. So what we would do then is we'd draw our three positions, okay? This is just for visualization purposes. We could obviously plug it into a formula. Yeah, but what would this first position be? Well, it could have 5 different people in it. It could be anyone from this initial group of 5 people. The second position could be anyone excluding the person in the first position. And this one can be anyone excluding the people from these 2 initial spots. So 5 times 4 times 3. You can imagine it like this. You have a starting location. You have 5 different paths that you can take, okay? For each individual person for your first position. And then after you picked your first position, for your second position, you have 4 different choices for each of those, right? And then you have 3. So 5 times 4 times 3 would equal the number of permutations that you have. That's equal to 60. And if we plug it into our formula, it also works. So let's think about this. It's going to be 5 factorial, right? Because our initial group number, so the amount of people in our initial group is 5. So 5 factorial divided by 5 minus 3 factorial. Whoa. Okay, and that's going to equal 5 factorial divided by 2 factorial. And that's the same thing as 5 times 4 times 3, which equals 60. Okay. Let's do one more example. And let's again go over some of the intuition that we talked about at the beginning of the video. Let's say that there are a set amount of numbers and you want to find out, so let's say there's a set amount of numbers 1 to 9, okay? And you want to find out how many different ways you can pull out 3 of those numbers and reorder them, okay? So, what can this first number be? Well, we know that this first number can be anything from 1 to 9, right? So it can be 9 different things, 9 different numbers. What can this second number be? Well, this number can be, this number can be anything from this initial amount, right? So this initial amount of 9, and we picked out 3. This number over here can be anything from this 9, excluding the number from this first slot. So for example, if this number over here was 1, this number could be anything from 1 to 9, excluding 1, okay? So this can actually be 8 numbers. This over here can be 7 numbers for the same reasoning that this has to be 8. Yeah, for some reason. Okay. So let's imagine it as a branch or as a series of paths. So at first you have 9 different choices, right? You can be your first position can have the numbers 1 to 9 in it, okay? And right, so let's just pretend that there are 9. Actually, let's actually draw the arrows. So there are 9 different paths that you can take for the first position, and then at the end of each of these paths, there are going to be 8 paths, and then at the end of each of those paths, there are going to be 7 paths. So 9 times 8 times 7, and that is equal to. Actually, let's just take out the calculator to be sure. 504. Okay. So 504, there are going to be 504 different options for finding out, for picking out 3 numbers from these, from this set of 9 numbers, right? Picking out 3 numbers and reordering them. So for example, I just want to make this clear. You can have maybe the series 1, 2, and 7 in each of yours positions, right? And the series 2, 1, and 7. And those would be two different permutations, just to make that clear. Okay, so let's try the formula as well. 9 factorial divided by 9 minus 3 factorial, in order to get 9 times 8 times 7. So if we had 9, just regular 9 factorial without this over here, then we'd actually be taking out 9 slots. But really we're only taking out 3 slots. So we need to divide it by 6 factorial. So 9 factorial divided by 6 factorial equals 9 times 8 times 7, which is equal to 504. Okay. That pretty much concludes this video. Thank you.